So why use scatter plots? When we use a scatter plot, we're looking to decide if there's a relationship between two different pieces of data. So here we're looking at the comparing heights and shoe sizes. And so we have a data table that has a listing of people and their shoe sizes and heights. And we went ahead and plotted those. And we can see that as our height gets larger, as we get taller, our shoe size goes up as well. And so that's what we call a positive relationship, which means, again, if the x value is getting higher, the y value is also increasing. And so this is also linear. I could do a line of best fit in here, which we'll talk about more in a different video. But you can see very much a line figure here. We have examples of where there is no relationship. So, for example, this is a table of boys' heights versus its birth month, and this is simulated data, but you'll get the idea. Does it matter what month you're born in? Your height? No, it does not. People born in that particular month have a wide range of heights, and there is no correlation. And it's why you see these dots all over the place. And so there would be no correlation here at all, or no association or trend line, depending on vocabulary you're using. Another idea that we have is that we get clusters of data, and that can be interesting. Here we have sort of a generic relationship here. It doesn't give me any idea what the variables they were comparing, but you can see that there is definitely a cluster of higher values with a bit of a break. I found this one about Old Faithful eruptions in Yellowstone. And while you have data all along here, and you can definitely see a linear trend line if you wanted to, there's definitely a clustering down here at the lower eruption times and the time between eruptions, and another cluster here where the eruption times are longer, but you also have a longer time between eruptions. For whatever reason, there isn't a lot here in the middle range. Again, there is a linear relationship there. There's also a positive relationship there. So the longer it erupts, it's been a longer time between eruptions, but you also can see that there is a cluster there as well. There's also a concept of outliers. This particular example is about miles walked in a week versus age. And so most people kind of do somewhere in between 0 and 10 miles, but we've got someone up here who did 50 miles in a week. Well, that's a lot of miles for walking. And so we would call that an outlier. It doesn't really fit into the data that we're looking at. And so if you're running an experiment and you get an outlier like that, you could either look at what your experiment was looking at, or did you do it under the same conditions? Was there a problem with that? Here we probably just have a unique individual. We won't necessarily want to make predictions and assumptions on that unique individual. So if we were going to put a line of best fit in here, or estimate what does a typical 50-year-old walk, it's probably not 50 miles. It's going to be somewhere around here in the 0 to 10 range. And if we really wanted to see, I could see that this is trending up. We tend to walk the older we get according to this. And so I could probably say a 50-year-old does about 10 miles, but this outlier is not a good example. And those are reasons why we use scatter plots in order to do some data analysis.